Welcome to the Explainer. Today, we're building an interactive infrastructure blueprint to really master Active Directory Domain Services, or ADDS. Look, whether you're studying for the Windows Server Hybrid Administrator certification or you just want to fully grasp the absolute foundations of modern network identity, this material is just fascinating. We're going to dig into exactly why things work the way they do. So, let's get started. Okay, let's take a really quick look at our agenda for today. We'll be covering 1. The hybrid admin shift, 2. Core ADDS architecture, 3. Kerberos authentication, 4. PowerShell management, 5. Demystifying those tricky FSMO roles, and finally, number 6, ADDS versus Azure AD. All right, kicking things off with Section 1, the hybrid admin shift, bridging the metal and the cloud. I want to start us off with a pretty fundamental question. What does it actually mean to be a hybrid admin today, especially when you compare it to the traditional role? Because, let's be honest, managing servers in a modern enterprise looks vastly different than it did even just a decade ago. Think about a traditional admin for a second. They essentially managed one physical server at a time. But a hybrid administrator, that's a whole different ballgame. You are literally managing Windows Server workloads in two places simultaneously, on-premises physical servers and up in Microsoft's Azure cloud. You've essentially become the bridge, managing entire infrastructures at massive scale using powerful tools like PowerShell and Azure Arc.
Moving right along to Section 2, Core ADDS architecture. You can think of this as the phone book and the security guard.
25 to 30%. That number is huge. It represents exactly how much of the AZ800 certification exam is dedicated entirely to Active Directory Domain Services. And there's a good reason for that. Fun fact, AD is used by roughly 90% of global Fortune 1000 companies. It's literally the backbone of enterprise IT. It acts as a giant phone book for storing user data and a highly strict security guard that controls exactly who accesses what. Now, to accurately map out our blueprint, we really need to define our boundaries. Let's do a quick quiz to test your baseline vocabulary. If a company has multiple domains that share a contiguous DNS namespace, say contoso.com and sales.contoso.com, what is this specific arrangement called? If you said a tree, you hit the nail on the head. A tree is basically a collection of domains sharing that contiguous DNS namespace. Now, a totally separate domain like fabricum.com, well, that would be an entirely separate tree. But the absolute crucial part to remember is that all of these trees can live together inside a single forest. The forest is the ultimate highest logical boundary of your entire ADDS deployment. It's the big container holding it all. Now listen, this point is absolutely critical. The domain controller, or DC, is the server doing the actual heavy lifting. If you only have one DC and it goes down, boom, catastrophic connectivity issue. Nobody can log in. In a real-world production environment, lacking a second DC means that if replication fails or a server crashes, you are going to immediately face broken trust relationships between your computers and the domain. You will literally be locked out while trying to troubleshoot offline. So rule of thumb, always have two or more. Which brings us to Section 3, Kerberos authentication mechanisms, the true backbone of your security. When we examine the backbone of Windows network security, a really interesting question pops up. When a user sits down at their domain-joined machine first thing in the morning and logs in, what default protocol is actually doing the security check behind the scenes? It uses Kerberos by default. When you log in, the domain controller securely issues you what's known as a TGT, a ticket granting ticket. Think of it like an all-access VIP pass. You then use this TGT to automatically request access to file shares and printers. This is exactly why your users aren't constantly forced to retype their passwords 50 times a day. It's incredibly fast, it's highly secure, and it's totally foundational to how the network operates. All right, let's shift gears to Section 4, PowerShell Infrastructure Management. Time to start building the blueprint. Knowing your PowerShell commands cold is a reoccurring pattern you're going to face, both on certification exams and just in your daily administration life. So, do you know which specific command helps you verify the health and status of your domain controllers? Let's look at how this builds into a perfect step-by-step checklist. Step 1, you use Install Windows feature to install the actual ADDS role. Step 2, you run Install ADDS Forest to create your forest, making sure to configure DNS while you're at it. And step 3, which is the answer to our question, you use get-ad domain controller. That command is going to let you view the health status, check the hostname, and verify if it's acting as a global catalog server.
Okay, take a deep breath. We are entering the gauntlet. Section 5, Demystifying FSMO roles. Active Directory has 5 Flexible Single Master Operation roles, or FSMO roles. And man, they are famously easy to mix up. This is a classic exam trap. Out of those 5, which specific role would you say is the most critical, responsible for handling password changes and time synchronization across the network? To keep these straight, I highly recommend using this visual memory aid. Categorize them clearly in your mind. There are exactly 2 per forced roles, the schema master and the domain naming master. Then there are 3 per domain roles, the PDC emulator, the RID master, and the infrastructure master. So our answer? It's the PDC emulator, a per domain role that handles passwords and time sync. Real quick, let me give you a list of common FSMO errors to absolutely avoid. First, never place the infrastructure master on a global catalog server unless every single DC is a global catalog. Just don't do it. Second, always ensure your PDC emulator is syncing with a highly reliable external time source. If time gets out of sync, Kerberos fails and nobody logs in. Finally, Section 6, ADDS versus Azure AD. 2 entirely different worlds. Now, this next concept catches people out all the time when they start moving to hybrid environments. So let's see if you know the fundamental difference. True or false, Azure AD utilizes organizational units, OUs, and group policy exactly like your on-premises ADDS. The answer is false. Absolutely false. They are completely, totally different systems. On-premises ADDS uses OUs to organize objects and relies on Kerberos for authentication. Azure AD, on the other hand, is a completely flat directory structure. There are no OUs. There is no group policy. Instead, it utilizes modern web protocols like OAuth and SAML. To get these 2 vastly different worlds to actually talk to each other, you have to synchronize them using Microsoft Entra Connect. As we wrap up, I want to leave you with this rather provocative thought regarding that schema master role we touched on earlier. Whenever you extend the AD schema, those changes immediately replicate out to every single domain controller. As the quote here states, schema changes are permanent and cannot be rolled back. So remember, in the hybrid infrastructure world, some structural changes are forever. The question is, are you fully prepared to make them? Thanks so much for joining me for this explainer,